test, test, test. Okay. All of my videos start out with test, test, test now, so that's okay. All right, so tonight we'll look at the output analyzer in Arena. So this is a little bit different. What we've been doing these last couple weeks with the process analyzer and the visual designer and the output analyzer is giving you some statistical methods to mine data out of your model. You know, determine a return on investment point, to look at different data and mine it out. The output analyzer is actually even better. You know, I saved this for the last because out of all the tools in Arena, this might be my favorite one that we have. So this is a pretty good tool. It allows the comparison of Arena model parameters and statistics using simulation model generated file name.dat files. So the one spreadsheet that we have not used thus far in the advanced process menu is the I just got to make sure it's in the advanced, I think it's in the advanced process menu, is the statistical spreadsheet. And that's what we're going to start using tonight. So Output Analyzer supports advanced statistical analysis of simulation model data. So, you know, here's a simple test model, and we'll do this one in a second here, but we'll talk about it first. We have parts arriving, and this is a really simple model. You know, I'm not about trying to build an extensive model tonight. I'm more about being able to look at the replications and the statistics behind the model. Parts arrive Expo 1 hours. They arrive to a process with seize delay release, TRIA 0.5, 1, 1.5. Now we're going to run the model for 100 hours, and we're going to run the model for 100 replications. One of the things that you'll see tonight is we'll do a lot more batch run. And the reason why we'll do a lot more batch run is when you run multiple replications of a simulation, the batches themselves take time. So if I'm going to run something that takes 5 minutes and I want to do 100 replications of it, you know, like on this last quiz, if I had to do 100 replications of that graph, you know, you'd have been here all week. But batch run in Arena allows me to run these as batches, but 100 batches or 100 replications, 100 hours each simulation. So you guys have seen this before, right? In your run setup menu, you know, you've got your warm-up time, your replication length. What did I do here? I actually circled the wrong thing there, didn't I? This is my replication length right here. Where's my number of replications? It's up at the top here, so I actually circled the wrong. Let me fix that real quick. This will be on my video too. That's the one I wanted to see there.
Everybody remember that way.
Yeah, there we go. So that's my number of replications right there. And this is 100 replications of the same model running for 100 hours. Okay, so it gives us more statistical data because these are random processes. There is some randomness from process 1, replication 1 to 2 to 3, and so on. And then when we go to build these, we're going to use the Arena statistics spreadsheet to create our own .dat files. I'll show you what that means right here in a minute. But these files, look at statistic 2 and 3. These are output files. So as an example, if I want to know the average Q weight or the whip cost, or if I want to come up with some expression that I want to save as a statistic that I'll use the output analyzer to analyze, then what I will do is I'll save them in a file location. And they'll get this .dat extension on them. So you'll see that in a minute here. And then from the output analyzer, you can go into the Arena folder in your start menu, open up your output analyzer. And then the .dat files will become the outputs I want to analyze. So I can see like OA QWeight.dat or OA whipcost.dat. What do you suppose this 100 represents?
The replications.
That's my number of replications, exactly right. It's an output statistic. and it has a statistic number associated with it from the statistics spreadsheet. So only the .dat files can be run by the output analyzer. So I know this. Some of this is like, what? You know, what's a .dat file? We'll see this in a minute. Then we can use that data, lump all of the replications together into one statistical analysis, like OA whip cost. And then I can do things like histograms. Now the nice thing about running this histogram, if I want to know this operation average Q wait, what percentage of entities had a wait time between 11 and 12 minutes? This histogram actually shows me the accumulation of all of this. And you'll notice cumulative data always goes up to what? Goes from what to what? In statistics. 0 to 1. Exactly right. And what this histogram represents is really the wait time with the greatest occurrences. So I can see right here if this is 0 to 1, 1 to 2, 2 to 3, 3 to 4 looks like it has the greatest number of occurrences. And I can see 3 to 4 had 25 occurrences. So this gives us a lot of data. So if I wanted to see what percentage of entities had a wait time between 11 and 12 minutes, I would come down here, find the cell limits 11 to 12, and I would find the percentage or the frequency, looks like 1% of them. Versus that 3 to 4 was 25% of them. And you can see the 25%. You can see it's up at the 25% mark right here on the histogram. Okay? And then if I asked, the neat thing about this then is you also get cumulative data. So if somebody asked you, hey, what percentage of our customers have to wait between 0 and 9 minutes? Now you can look at cumulative data, and you can see the cumulative data over here. So here's 0 to 1, 1 to 2, 2 to 3, all the way down to 9 minutes. The cumulative data is right here. So 90% of my entities waited between 0 and 9 minutes. That means only 10% of my entities waited beyond 9 minutes. Kind of a cool deal. You know, then I can also look at it from cost perspectives too. I can list in there what it costs to have work in process. You know, if having 100 entities in process cost me, you know, $6 an entity, I've got $600 work in process. Now I don't know what the costs were in this particular one, but what I can see is what percentage of time has less than 6,000 work in process. I can actually see where 6,000 starts and what percentage less than 6,000. Okay, or what percentage is greater than 10,000. I can see all of that. And the line on here, the histogram, represents the number of occurrences, and the line represents the cumulative data over that time from 0 to whatever cell you're going to. All right, so let's go ahead and build one of these. So what I want you guys to do is open up Arena. You can close out the Visual Designer. We're done with the Visual Designer for tonight. One of the things I was going to mention is so this week we'll go over the Output Analyzer. This is the last of the new material for the course. So that's the good news. Next week we'll come in and we'll do a review. And the last week, you guys will come in and like the midterm, it'll just be a final exam alone. So one of the cool things is you do have homework due next week. Okay? However, you won't have homework due the final week. That's kind of a nice deal for you. So that week before the final, you can just study for the final. I will tell you that the final is there's a lot. Okay? There's going to be input analyzing, there's going to be building of an arena model, and there's going to be animation and a visual designer. So you're going to have a lot of pieces involved in that. However, I'm not. It doesn't have to be a visual designer. Some of the stuff you will have to have animation, but you may not have to have the visual designer. You could use the output analyzer. You could model variables in Arena. You got to answer the questions for the final. You don't have to give me screenshots of visual designer screens or anything. So, all right. So let's do what we were doing in the PowerPoint here. What we're going to do. Yeah. What's that? Oh yeah, we're having a quiz next week. Yeah.
Come on.
Yeah, so this is the last normal week. So homework is due on Wednesday, quiz on Wednesday, and then no homework due on the week of the final, and no quiz, just the final exam. So, yeah. Isn't that a good deal?
It would be better if it wasn't a quiz.
Yeah, it would be better if, there's still going to be a quiz, though. Oh, well.
A quiz on the same day as the final would be kind of outrageous, really.
Yeah, we won't do that. I promise that.
Won't do what you do. Yeah.
All right. Here's what I want you to put in here. I want you to put in a... does it always do that? It just did something that I was kind of...
What?
If you take the process and set it on here, it does break the line?
I told you that once. Yeah, you told me.
All right. Okay.
You gotta pay attention, man.
Yeah, I get. I normally don't have the lines already hooked up.
You shouldn't sleep in class so much.
Yeah, apparently. So here's the deal. We're going to have a create block, a dispose block, and a process block. Okay? This is the most simple model you'll ever build in this class. I think it's the same model that we built the first night we used Arena, right? Mm-hmm. So this is as simple as it gets. The part arrivals is going to be Expo 1. So I'm going to call this part arrivals. Entity 1, Expo 1 hour. I'll leave that alone. Give you guys 10 seconds to type that in. Random Expo 1 hour. 1 entity per arrival. Max arrivals infinite. Okay. Just got to go back and flash up my PowerPoint here. Okay, SDR. Got it. So then, in here, we're going to have a seize delay release for the process. I'm just going to call it process 1. I'll add a resource resource name of machine 1. We're not really defining this one very well. So I've got process 1, seize delay release. The resource is machine 1. The distribution is going to be TRIA 0.5, 1, 1.5 hours. And then hit OK. Now, what I told you guys was that in order to model data that we can use in the output analyzer, we need to use the statistics spreadsheet. Unfortunately, the statistics spreadsheet is not in the basic process menu. So we need to add in, go to File, go to Template Panel, Attach. We want to add in the advanced process, not advanced transfer, advanced process template. I'm going to show you how to get to there. I know some people may still need to get to there. You can always get to there by going to C, go to Program Files x86, going down to Rockwell Software, Arena, Templates, Advanced Process Template. Now, because of our license, it may give you an error. It says, because we're on an educational license, it'll give you that authorization error, but it will allow you to use it with limits. So you don't have to worry about it. Now, once you're in the advanced process menu, if you scroll down, you'll see you get a statistic spreadsheet. This is the spreadsheet from where we want to define the data items that we're going to look at in the output analyzer. So what I'm saying there is if I go into the statistics spreadsheet, and I cannot remember what ones I looked at. Oh.
You should have printed that bigger.
I did Q8, WIP cost. Okay, I did averages. So here's the deal. What we'll do is let's go into the expression builder first. If you go into your expression builder, if you go to Q, we're going to look at the average wait time. Okay. So average wait time. So that is my average wait time. Now once I have that, again, I can just click on OK. I only have one process, so I don't have to worry about selecting anything. That becomes my average wait time. Then what I'm going to do is I'm going to double click to add a new row in the statistics spreadsheet. Okay, double click, statistic 1. This is going to become, now this part's important. And you can actually rename this statistic 1. If I wanted to rename it average Q weight, I could do that. So now that's statistic 1. Instead of being called statistic 1, it's called average Q weight. This is the really, really important part. This is in your textbook, section 9.6. If if you're at home actually reading the textbook, which I know you guys all go home and do that. So if you're looking at section 9.6, it's actually going over a similar model to this. Now instead of tally, what I want you to do instead of tally is I want you to go to output. We're using the output analyzer. We need our statistics to be output to the output analyzer. And then it's basically walking you through everything you need. So the next thing it wants is the expression. Well, I just did that in the expression builder. So I hit Control V. There's my expression. Okay. So I went to output. I'm going to go over here for a second. Go back to output. And then I pasted it in here.
I did. Oh, there you go.
And then it should look good. And it gives you a report weight too. It's pulling that right off of the name here. So whatever you name that, it's going to give you as a report label too. Now the trick here is you need an output file. You need an output file. What this is going to do is when you run your replications, it's going to save it to a .dat file, which is what you're going to use to model your statistics. So I'm going to go to the output file, right here, the .dot. Click on this. What's this thing called, computer guys? .dot. Ellipse? Ellipsis? Ellipse. So I'm going to click on the ellipse, and then now I basically have to give it a file name and a location. So what I do is I go back to where I save all my arena files. So I've got an IENG 4210 folder. And I go back into arena files. And then in here, I'm going to save this as average Q weight .dat. I think, yeah, it doesn't tell you that, but you need to save it as a data file, .dat. Now, I don't know for sure how that .data file comes in, if it comes in as comma separated values, or it comes in as a list, or how it comes in, but it comes in as raw data into the output analyzer so the output analyzer can use it. So if I hit OK, yep, .dat. So if I hit OK now, what's going to happen is, if I expand this out and look, it's going to actually show, I'm going to make the other one smaller here so we can see it. Yeah, as long as it's a .dat.
Does it automatically put the DAT after it?
No. No, it will not. It'd be nice if it did, but it won't. So I can kind of see what's going on here. I guess I'll go this way a little bit.
If you double click on those lines to resize them, I get extra stuff showing up.
What do you mean?
You know, like your sizing columns in Excel where you double click on it, it automatically sizes.
Oh, like over here?
No, like between report and output file.
Holy crap, yeah, you get much more stuff.
Scroll to the right. No, put it. Okay, go to the right a little bit. Go to a little bit.
Okay.
A little bit to the left. A little bit to the left. Right there, double click to resize the column.
Yeah.
Well, if you do like at type, I get a bunch of columns popping up.
Oh, do you?
Yeah.
Okay.
I get tally name, tally output file, counter name, limit, report label, output file.
Okay.
Collection period.
Well, the only one we really care about at this point is the output file. We need to have the expression right. That's really important.
Can't even get rid of them again.
and I need to have the output file right. What? You got to have the right file type. .dat. Yep. I'm trying to see if I can. I have no way to show that to you because my projector is making my screen smaller. But it's basically showing me exactly where that file is storing. Well, there you go. If I mouse over it, you can see it's storing C, users, DAEV, all my network location there, documents, my folder names, and then it's average queue weight.dat. That's the important part of this. Now let's do another one. If you double click to add a new row, now instead of average queue weight, let's call this one average WIP cost. So I'm going to do average queue weight, average WIP cost, and I'll do this one also as an output. Now the neat thing is when it brings up that yellow, we know it's looking for an expression. So we'll go into the expression builder and see if there's a way to determine average WIP cost. Oh, right in the yellow there? Right click, yeah, nice. Right click, build expression. Perfect. So WIP is going to belong in your process, number in process. So process1.wip is what's going to happen. When I go to process, number in process, and we'll say that they're, I don't know, $500 per entity in process. Now, the trouble though is, I don't know if I'm not really getting average WIP, am I? I'm really getting live WIP doing that, aren't I?
Yep.
Let me look at something here real quick. Yeah, I don't know if I can do T average for WIP here. I'll look at the PowerPoint and see what I did before. I guess I don't know. Oh, I just did process 1 WIP times 500. So I don't know that we're really calling it. So we'll do the same thing. Process 1.WIP times 500. If I was looking at like the average of something over how many entities come out or something, I could divide by number out. But in this case, I'm just looking at WIP. So we'll just do process 1.WIP. And what does WIP include? The one in process and the queue length, right? Yep. Versus NQ determines only the queue length and will typically be off by 1 if you're looking for WIP. $sign for what? Oh, yeah, I don't want that $sign. No $sign. Good call. Process 1.WIP times 500. Hit OK. That's going to go in here. Oh, notice it pasted it right in there. I didn't even have to hit paste. Okay. And then we're going to go to the output file again. And you know what I'm going to do? Instead of calling this average WIP cost, I'm just going to call it WIP cost. Is all I'm going to do there. And then under output file, we're going to click on this again. We know we're going back into here. We're going to call it WIP cost.dat. For file of type, it will just list all file. It won't give you .dat as a selection. Type is output. Yep. And I accidentally ended up with an extra statistic down here. I can always right click on that and delete that third row if I don't need it. Yeah, so WIP cost, the type is output. The expression is process1.WIP times 500. The report label is WIP cost. That comes straight from the name. And then the output file, .dat. Absolutely. So there it is. It's in that same folder, WIP cost.dat.
say it's different files?
Yes. Yeah, so these are going to be two distinct data files. You guys remember what with the input analyzer? Here's the way to think about it. Do you remember with the input analyzer, we had to have raw data, and we even had to do some special formatting to bring it in. You guys remember that? Like just having it as raw .textpad or notepad file. We had to bring it in as raw data or comma separated values into the input analyzer to model the distribution functions. Now we're going the other way. Now we need raw data coming out to build the histograms for the output. So it's very similar that we want raw data, except unfortunately it's coming from Arena now, so it doesn't save it to Notepad. We tell it it's a .dat file, which means it's just raw numerical data that I've never tried this, but I have a funny feeling you could take a .dat file. You probably could import that into Excel. You could probably import that into Minitab, and you could analyze it with statistical tools from those other areas. The beauty of Arena is we know what the time function looks like for that process, but it's not an easy thing to just calculate, using numerical methods. We need to model it to get the raw data out that we can then use to calculate the statistics on. So there's a lot of moving parts to this. So now once both of those are saved, we're going to go to Run. We're going to go to Setup. Oh, and by the way, what should we do right now? File, Save As. I've seen a lot of crashes when working with Visual Designer. There's a lot of crashes, and the reason being, again, it's a Windows function, and we're running multiple applications at the same time. There's a lot of room for crashing. So I'm going to call this my, let's see, we'll call it, we'll just call it Output Analyzer Demo. Oh, I should put in my comments up here, yeah. Inside process 1? Yeah, I just defaulted on all of the processes. Expo 1 for arrivals and TRIA 0.51, 1.5 hours for process 1. Where I'm going to change things now is under the Run Setup. Under the Run Setup, we're going to do 100 replications. The length is going to be 100 hours, 24 hours per day. So this is different up here. 100 replications we're going to run. Okay, when we're doing statistical analysis, and again, the beauty of Arena is it doesn't cost us any money to do 100 replications or 1,000 replications. If I'm rolling dice and I want to statistically model how they roll out, well, I got to roll dice all day long. Arena just does it, so I don't need to do anything. So 100 replications, no warm-up time, 100 hours for replication length, 24 hours per day, base time units hours. I hit OK. Now what I'm going to do is I'm also going to go into Run, and I'm going to Run Control, and guess what I'm going to do? I'm going to go to Batch Run. I'm going to turn off the animation. I don't want to see an animation at this point. So I hit Batch Run. I'm no longer going to see animated files. What you'll notice is when I run this, I'll run it at about half speed. When I go to run this, what it's doing is it's counting the batches down here. Let me run through that one more time. I'll run it a little slower this time. If I run it, you'll see it's counting the batches. It actually goes really quick regardless, doesn't it? There's 100 out of 100 batch runs. All my replications are complete. If I want to go look at my results, I go to the results. You can see that the number out was average, 92. Now, why does it say number out average 92? Yeah, a lot of times we'll have just true number out there, right? Except now, that's an average of 100 replications is what that is. So it's giving me some statistical data right off the bat. But better than that, what I want to do is I want to minimize Arena now. I want to bring Arena down, and I want to go in to All Programs, minimize this, Start, All Programs, and I'm going to go down to Rockwell. And in the Arena folder, we now have used everything starting tonight. We've used Arena. We've used the input analyzer. We used the output analyzer tonight. We've used the process analyzer. And we used one other thing that it's not shown. What's the other thing we used? The visual designer, yeah. So what we're going to use tonight is the output analyzer. Click on that. All right, now what we want to do is open doesn't do anything for us. Open would be if I wanted to open up an output analyzer file, a .dgr file. We don't have any .dgr files. What do we have? We have .data files that were generated by our replication run. So we're not opening a .dgr. Now, when you guys, go to turn in your homework, you'll submit your output analyzer file to me. You'll save it, and that will be a .dgr that you'll submit to me with your Arena file. Okay? You don't have to submit the .dat files because they'll be embedded in your .dgr file, and I can get the .dat files by running your Arena. Does that make any sense to anybody? I can get the .dat files when I run your Arena simulation, so therefore you submit the .dgr files. Now, anybody see a problem with that when you submit it to me? This happened to me it's happened to me every semester I taught this. There's one minor problem with this, is when I go to run your Arena file, guess where it's trying to save your .dat files? to a location on your computer. Doesn't work for me, right? No problem. I just go in there and I change the location and I run your simulation and I run your .dat. So it's all the same stuff. I just have to change the location. So we're not going to open an output analyzer file. What we're going to do instead is we're going to go to New. We're creating a new output analyzer file. And we're going to look at what data group files we want to look at. Well, we created the data groups. Those are your .dat files. That's your raw data. Those are the groups of data that we want to analyze. So what I'm going to do is I'm going to add a .dat file. Now, because this is the first time you've opened the output analyzer, you're probably going to have to go in and find where this stuff's stored. Hopefully you know where you stored those .dat files. Drill into that file. So for me, I would go into Libraries, My Documents. I'd go find IENG 4210. And then I would go to Arena files, and that's where my .dat files are. Now, all of my Arena files in there, my DGR files, my Visual Designer files, A23 I think they are, DAT, and all my DOE files are all in there. But it's only going to show me the .dat files. I could look at all files, and it would show me everything that's in there. Okay, but I don't care about everything. I only care about the things that are .dat. And so in here, I should look at date modified. There's the two. You'll see all the trial files I've been running this weekend trying to get ready for you guys here. I have average Q weight, which I'm going to open. And then I'm going to add one more, which is whip cost, .dat. Those are both going to come in as files over here. Again, average Q weight .dat, what does 100 represent? Number of replications, it's an output from Arena to us. Whip cost.dat, 100 replications, an output from Arena to us. These are the item names or the statistic names. Now what I want to do is I want to do some statistical analysis around these. There's a lot of different things you can do. Probably one of my favorite ones to look at is the histogram. We like histograms when we do statistical analysis because histograms allow us to do things like look at the bell curves, look at standard deviation, look at what type of data we're looking at. So I'm going to click on histogram. Before I do it, though, I'm going to do it actually, it doesn't matter. Click on histogram. Because right here, I can select which one I want to look at. Do I want to look at average Q weight? These are the only two I've set up. Average Q weight.dat or whip cost.dat. I'll go to average Q weight.dat. I can give this thing a title. I can call it average wait time or something. And I'll say process Q. So that's going to give me my title. I can give it an x-axis label, which now I got to think of how this is going to come in. Coming in what? Our base time units was hours, right? So it's going to come in as hours. Okay. The histogram cells, I don't use a whole lot of this stuff. You can get pretty detailed in how you're labeling everything. So at this point, let's go ahead and hit OK. Oop. It didn't like that. So let's try that one more time. Histogram. Hours. Ending time must be greater than the beginning. Oh, here we go. Go to lumped. Ending time must be greater than beginning. I'm trying to think of what's causing that. Well, either way, we should go to lumped data. What's the difference here is we have lumped replication data. Be really, really careful with this one right here. Here's what all will do. Okay? What all will do is it'll generate a histogram for every single replication. What does that mean? You're going to get 100 histogram windows popping up on your screen. We don't want to do that. We want lumped data. And I'm trying to think if we should be good. Oh, there we go. Yeah, there's my lumped data. I'm guessing the reason why I was giving a little bit of an error there is because what we were doing was the model, the data model, was set up for 100 replications with 100 hours. And we were trying to do a histogram off of one replication with 100 hours. So you should always click on that to see what you got. Now, if you look at this data, you've got a lot of stuff in here. You can see the most common. This is different now. You know, we're used to looking at things like means, minimums, and maximums. That's what I've been asking you the whole class is, what's the maximum queue length? At what time did the maximum queue length occur, right? I've asked you that 100 times in this class. Or in the most recent one, at what time did our ROI, our break-even point occur? In this case, I can start asking you more detailed questions. I can ask you, what percentage of entities experienced a wait between 4 and 5 hours? And you could come down here and go down to cell 5, which has cell limits of 4 to 5 hours. How do I know it's in hours? Well, two things. It's up here in hours, but it's only up here in hours because I put hours. Because my base time units were in hours, right? So that's important back in Arena. So I can look and say, okay, between 4 and 5 hours, we had the absolute frequency was 8. The relative frequency was 8%. So that means 8% of the entities that went through these 100 replications had a queue wait of 4 to 5 minutes. Okay. Now, what does this number over here mean, though?
That's cumulative.
That's the cumulative. So that means if I asked you what percentage of cells had a wait, or entities had a wait between 0 and 5 hours, what would you say? 66.67%. Okay. But I can also ask you kind of strange things too. I can ask you things like, what percentage of entities had a wait time between 12 and 13 hours? What percentage of entities had a wait time between 12 and 13 hours?
1%.
Oop, I'm grabbing the wrong one here.
Oh, no, 0%.
0%.
I was looking at the line above.
Look at this. The absolute frequency was 0. Okay? Or if I ask you something like, what percentage of entities had a wait time of greater than 5 hours? What would you say? So wait time of greater than 5 hours is all of this stuff. So you'd be, how would you calculate that?
Well, 66 minus
1 minus 0.6667. And you'd come up with 0.3333. Had a wait time, an average wait time of greater than 5 hours. And I know it's greater than 5 hours because this one starts at 5 and goes to 6, and everything down here is bigger. This one starts at 4 and goes to 5. So you can see your cumulative data up on this graph up here. So that's your cumulative distribution growing from 0 up to 1. These are your cell distributions. This is your histogram. What's the most common weight?
4.
3 minutes or 3 hours to 4 hours is the most common weight. Okay. All right, so let's leave that one open. All right, we can just minimize that one for a second. Let's add another histogram. So we'll click on histogram again. And instead of doing average Q weight, let's look at WIP cost. And so I'm going to change the title to WIP cost. I'm going to change the data axis label. Oh, I'm not even sure what those is. Dollars? Must be dollars. Your X. I got to think about that for a second. I'm thinking your Y is dollars. But either way, we'll leave it alone. Hit OK. Let's see how this thing comes up. All right, now notice one of the things it does here is it and I don't know that that's not, yeah, that is dollars. That's absolutely dollars. We're good there. Remember that your cumulative, your y-axis, represents your percentage. So it's going to represent, over time, it's going to represent the accumulation of all of the entities and what they're experiencing for WIP cost. Okay? So basically, yeah, the absolute frequency from 0 to 1,000, we had 14.
Is that times 1,000?
Yes. This is times 1,000 up here. So, so this 5 to 6 is 5 to 6,000. You can actually see that down here, though, 5 to 6,000, and where it's 5 to 6 here. Now, let me ask you a real quick question. This absolute frequency, what do these numbers add up to in this column right here? Yeah, so this one is a little bit different because if we go look at this, let me go look at this, this statistic real quick. So process 1.WIP times 500 is your WIP cost. So really this, yeah, this is adding up to 100. This is the number of, well, I wonder if that's the number of batches, if that's the finishing batch. I got to figure that out now. Interesting. Well, we know this. We know from negative infinity to 0, we had no accumulations. From 0 to 1,000, we had 14. I think these are going to be batches with $0 to $1,000 of WIP. We had 9 batches with $1,000 to $2,000 of WIP. 15 batches with $2,000 to $3,000, and so on and so forth. So our most common one would be to have $3,000 to $4,000 of WIP, which would make up 20%. Again, we can look at the accumulation of the data up there as it goes on. Now, there's a lot of different plots. I gotta get my head around on really what that means, because I'm not sure when that WIP is being measured. You know, if that's at the end of a batch, I've got a funny feeling it is. So what this is saying is that this is saying 14 of the batches ended with 0 to 1,000. 9 of the batches with 1,000 to 2,000 of WIP. That's where I would like to have that be an average number, just because it's kind of a strange thing to look at there. But Down here, this is a really big number. This is from, what was that, from 1.4E, yeah, 1400, or actually plus 004, 14,000, all the way up to infinity. Really, we're probably seeing those right here or anything bigger than 15. So, all right. Does that kind of make sense, guys? Other things you can do, and I don't know that these are going to work for what we've got going on. You've got the histogram. You can also do a moving average. If we click on moving average, I have no idea what this is going to look like, but we'll try it. Oh, and it's showing me all my old ones. So I might have to hit browse just to see the one I want. So here's my whip. Now let's do the average Q weight, because that gave me better data, I think. We'll do 100 replicate. Actually, we'll do clumped or lumped. Lumped. So there's a moving average of all of the data. Now this is kind of cool because it shows me deviations, the total absolute deviation and the mean absolute deviation, and it shows me a moving mean of all of the data over time. So here's my 100 replications and my average Q weights over those 100 replications. So what you would see is every single dot on here represents a replication, every little single set of crosshairs. So what's kind of interesting about this is you can see, like in replication 39, the average Q weight was really, really big. However, in replication 42, the average Q weight was really, really small. We can start to see how the random data can be smoothed out over time. All right, so that's your moving average. You can also plot in here. But again, any plotting or any stuff you would do in here has to come in as what? Has to come in as a .dat file, right? So I'm going to add a .dat file. I can browse this. I have no idea what this is going to... We'll do whip cost this time. See what happens here. 100 replications, all lumped together. And I'll just hit OK and see what happens. Yeah, so that's just a plot of my whip cost. Again, I'm not positive. I'm really not positive what we're measuring there, whether that's an average whip cost over the batch or if that's an ending whip cost at the end of the batch. Because it's only one data point, but we know that the whip cost over the batch run itself is doing this, right? It's changing over the batch run itself. So, I don't know that whip cost in that particular case does me a whole lot of good, but you can see how you can plot something. Batch and truncate, parallelogram, confidence interval. I don't think we can do that. We'll try. We'll see what happens here. Data file. Whip cost, lumped. Well, let's give me a confidence interval. So let's see what this is showing me here. It's showing me that the 95% confidence interval goes for a whip cost between 3,470 and 4,830. That's my confidence interval. Now, confidence intervals are really important because this really determines, whether or not this is a good graph. We'll do things, for those of you guys that have done statistics with Mike White or done any other statistics classes, we do p-tests, and there's different tests you can do to look at confidence intervals, look at things that whether or not they, the null, whether or not it's differs from the null response. So that's where confidence interval can come in handy. All right, anything else on there? I'm gonna try the parallelogram. I don't think it's gonna do anything for me here. We'll give it a whirl though. Lumped. Well, there you go. There's a parallelogram. So this is my sample mean, which includes all of my data, is 4,150. My variance, my sample size of 100, my weighted sum, and all of my data there. So there's way more stuff in here than you could ever even look at. Batch truncate. I'll do the other one here. Lumped. Oh, that didn't do anything. Try that one more time. I got a million of them open here. Yeah, I need some more data to do that. So the typical things, your bar chart, your histogram, your moving average, your plots, all of these we can use, the parallelogram, the confidence interval, all of this stuff is available as statistical data now to you inside of Arena on the Output Analyzer. So how are we going to use this? Let's take a look. And we'll take a look at the homework, which will also be very similar to the quiz. All right, so here's what we're going to do for the homework for next week. Again, coming right out of Chapter 9. Basically, create the following model, answer the questions on page 2. You must submit this document. Yeah, I guess I didn't, in this case, I'm not actually going to ask you for the Output Analyzer file. So you're going to submit this paper document and your Arena model for credit. So in this particular case, we have gear arriving. We unpack and test. Unpack and testing is SDR TRIA 5, 7.5, 10, where the gear arriving is TRIA 8, 10, 12, all in minutes. We go to a decide block, two-way by chance, 70% true. Very similar to one we've done in the past, where 70% require calibration only, 30% will require troubleshooting and calibration. And then they'll go to a workstation, and they will have differing work times, where calibration will have a work time of TRIA 6, 7, 8, and troubleshooting and calibration will have a work time of TRIA 11, 12, 13. And how do I have two different work times for this workstation? The assign blocks. We'll assign a work time variable, and rather than having this process be a distribution itself, its distribution will be the work time variable. So it can get that work time variable by the entity that's coming in. So the workstation is SDR, but I don't need to give you a process or a distribution because the distribution is the corresponding work time from above. And then the resource will be technician. Then what you're going to do is you must create a statistics spreadsheet item for each graph you plan to generate. So the first thing you'll do is a histogram. Output Analyzer histogram T-average workstation.q.waiting time. A little different, right? You guys can pull that right out of the expression builder and then paste your histogram here. Then the questions you're going to answer are, what percentage of entities will experience a workstation Q wait between 0 and 0.029 minutes? What cell range wait time had the greatest absolute frequency? And then down in moving average, all I did here was basically paste the moving average 1 graph here. Output Analyzer moving average graph for revenue. And you'll use entities out for each entity times 1,500 per entity. So this will be the moving average for revenue is what that'll be. And that's all I need is I just need the Arena, that worksheet with your plots in there, and that's the whole 9 yards. Any questions on the homework? Other than us being done early. Yeah. So here's what we'll do. The homework and the PowerPoints are posted. I'm gonna stop the video. Anybody